We also have biomass energy, which is the burning of plants as a source of energy. And this can include corn and other types of alcohols that are made by plants. So our non-renewable energy are our fossil fuels, and the Industrial Revolution made use of fossil fuels, things like coal, and then years later natural gas, and years later nuclear energy. So these are all non-renewable energies that do come from resources extracted from the earth. Land is also considered to be a resource, and it is describing the form of land called arable land, which means that things can be planted on it. It comes from the Latin word arabilis, and that means the ability to be plowed. And again, if we think about when man switched from hunter-gatherer into agricultural type living and societies formed around agriculture, the division of labor became possible, and it advanced society, and man's existence on earth improved. So here's an example of a GIS map of arable land, and this is showing you percentages of arable land around the world. So in terms of cartography, I want to point out to you, this is not a good map. So why am I showing it to you? Well, I wanted to show you that the information is valid and it's a good source of information. However, it is from a Wikimedia. And I wanted to kind of point out to you that with the access of unlimited information on the internet, I hope that you make a concerted effort to be a distinguished consumer of information and a very critical consumer of information. So again, the message here is good. The data is valid, but this type of map product is certainly not something you would want to share or create. It's not complete. And so there's a lot of map elements that are missing that would give the reader information. And I told you what the color bar means on the right, but this map does not tell you, and that's not a very good map. Um, you need to have a lot more detail on here. You need to have units, or you need to tell the reader that it's percent. There needs to be a projection, a north arrow. Don't ever assume that north is at the top of your map, and things like that. So we will be going into that in a lot more detail in your hands-on exercises, but I just wanted to show you again. I'm going to start off with what not to do, and then we're going to progress and look at some really good maps later in the course. So going back to land resources, so it's the most important, among the most important of natural resources. Even though land is only 29% of Earth's surface, as you can see here, most of Earth's surface is covered by the oceans, 70 to 71%. And land makes up 29%, but that's where humans live. And this graphic is showing you good land that can be farmed in green, mountains, area that's covered by snow, dry land, which is arid, and also that is deserts, and then land that doesn't have topsoil. And these dry land, land that doesn't have topsoil, covered by snow and land, and mountains, all of these are not very good areas for farming. And so when we really get down to land as a resource in terms of sustaining human population, this is about the chunk of land. It is only a small fraction of the entire 30% of Earth's 29 to 30% of Earth's surface that is available to us for agriculture. So there's also an uneven distribution of population in different parts of the world, and this generally follows land and climate. So this map is a little bit better than the last one I showed you. There's still no north arrow and there's no projection, but we're getting better. Again, if you look at the caption on the bottom, it is from Wikimedia. It is a commons. So again, please be discerning in the maps that you use, it doesn't mean that this is not a good resource. It means that this is not a professional map layout. And as burgeoning cartographers, you will get more skills than this person put into the map. So if we want to look at the information, we are looking at different colors on the map that represent different areas of the world. And this is the Köppen climate classification system that should also be on this map. And the colors you can see correspond to our legend that we have over here in the left. And so if we look at where you are in Texas, it's probably either temperate steppe, or you might also be here. Yeah, probably temperate steppe is about where you are located right here. And for instance, if we were to consider ice sheets and polar deserts, we could look and see that most of Greenland is in fact an ice sheet. And a couple other things, if you wanted to say, for instance, look and interpret this map and say, where in the world do we find the driest areas? Well, we would do some research and find out that arid desert, xeric shrubland, dry steppe, and semi-arid desert, these are going to be the driest areas of the world. So if I'm going to look for these shades of brown and green and tan, I'm going to see a big pattern right here jump out at me in Africa. I'm also going to see a pattern that covers most of Australia, and I also see a pretty big pattern of that arid desert here in the United States. We do have some dots on here that are showing you cities with at least 1 million inhabitants. So if you think about those two data sets for a moment, what patterns do you see? That was a quick 2 seconds. I think that was 2 seconds. So I am seeing that we have more cities with a lot of inhabitants in areas that are coming from these shades of green, the darker shades of green. And if I look at my map, I can see that these areas of green tend to represent grass, trees, savannas, and subtropical dry forests and tropical rainforests, as well as subtropical rainforest. Now, the order of these climate classification zones has to do with the Köppen classification. And so this is an interesting palette of colors here. Again, looking at that cartography, if you're looking at Köppen classification, you do need a very complex color palette. And the user of this kind of map would really want that kind of detail and that kind of juxtaposed colors next to each other, because that's how the real world is. Now, if you were making a map showing other kinds of data, you would not want to use this kind of color pattern. It is difficult to interpret. We will get into that more with symbology. Again, I just want to point out to you that sometimes chaos is important in your data message.